Hello everyone, welcome to the course on operating systems. In this session, we are going to discuss about the system calls related to the memory management. A program under execution is called as a process, and a process needs memory space in the main memory. That means whenever a program is executed, it has to be brought from the hard disk space to the main memory. And on the other hand, whenever a process is in the waiting state or it is in the ready state, it has to be brought to the hard disk space in order to make room for other processes that are currently executing in the main memory. That means at any given point of time, there may be many processes executing, and whatever the available main memory may not be sufficient for all the processes that are currently executing. So in such a case, whatever the process that are either in the ready state or in the waiting state, they can be moved back to the hard disk, and whatever the process that are currently running, that means whatever the process that are in the running state only will be allotted space in the main memory. So whenever a process is in the new state or it is in the waiting state, it has to be moved to the secondary storage, and in such a case, some space or some memory has to be reserved for the process that have to be moved to the hard disk space. So there are certain system calls that enable us to make room for the process in the hard disk, and also whenever they are required, again they can be brought from the hard disk to the main memory. So this process is called as swap in and swap out. So the process of moving the process from the main memory to the hard disk is called as swap out, and the process of getting back the process into the main memory for execution is called as swapping. Now let us see the system calls that are used for creating the memory space in the hard disk, and accordingly the hard disk space should be mapped to the main memory space. Let us see those system calls. We have four important system calls related to the memory mapping with respect to the implementation of virtual memory. The first one is MMap, which describes memory mapping, and which is the function that is used for mapping the files or devices into memory by creating new memory regions. And similarly, we have the other system called MUnmap, which is the reverse process of MMap, which is used for memory unmapping. It removes the mapped memory regions. That means it releases the associated memory which is allocated during the MMap function. The next system call is sbrk, which stands for set break, which adjusts the program's data segment size, that is the heap size. So if a process includes more number of functions that require dynamic memory allocation, in such a case, the heap segment space that is allocated to the process has to be increased. So that can be done by using the sbrk system call. Next, we have MProtect, which stands for memory protection, which is used for changing the memory region's protection level. And this is the prototype of the MMap system call, which includes the parameters address, length, protection level, flags, file descriptor, and offset. Let us see the description of each of these parameters. Address, which is the first parameter, which represents the starting address of the mapped memory region. That means whenever a new memory region has to be created, we have to indicate what is the starting address of the memory region. And if nothing is specified, then operating system or the kernel chooses the address. The second parameter is the length, which represents how much amount of memory region has to be created and mapped to the main memory. And the length is represented in terms of the number of bytes. The next parameter is protection level, which represents the memory protection, which may include the read, protection underscore read, that means the read protection. That means whatever the memory region that is mapped is given the read permission, only read permission. And similarly, we have write permission can be given by using the protection parameter PROT underscore write. And similarly, execution permission can be given by using PROT underscore exec. The next parameter is flags, which determines whether the updates to the mappings are visible to the process that are mapped to this particular memory region that is being created. And we have different flags, including map underscore shared, map underscore private, and map underscore anonymous. So basically, it represents how the updates that are being made to the mapped memory are reflected to the other process. The next parameter is FD, which is the file descriptor for file mappings, or else it returns -1 when map underscore anonymous is being used. The last parameter is offset, and this is the offset within the file, which is exclusively for file mappings, and it represents from which to start the mapping. And it is set to 0 for non-file mappings. And the function MMap returns a pointer to the starting address of the memory region that has been created if the operation or if the memory operation is successful. On the other hand, the MMap returns map underscore failed in case of an error. The next system call is MUnmap, and this is the prototype of MUnmap, which takes two parameters. The first parameter is ADDR, which represents the starting address of the memory region to be unmapped, and this should be the same address that was used when the memory region was initially mapped with MMap. As we have seen, the MMap function is used to create the memory mappings, and on the other hand, MUnmap is used for releasing the memory mappings. The second argument is the length, which is in terms of bytes of the memory region to be unmapped. ADDR specifies the starting address and length specifies how many bytes have to be released. The MUnmap function, it returns 0 on success and it returns -1 on failure. If MUnmap is successful, it indicates that the specified memory region has been unmapped and any associated memory is released. On the other hand, in case of an error, MUnmap returns -1, and you can check what is the error that has occurred during the MUnmap function by using the variable error number. The next system call is sbrk, which takes only one parameter. sbrk stands for set break. And it takes one parameter, which is increment, which is of type int ptr underscore t. And an int ptr underscore t type represents the number of bytes by which to increase or decrease the program's data segment or heap segment. And this particular system call is used only in order to increase or decrease the size of the heap segment space that is allocated to the process. If the increment value is positive, it increases the heap segment. On the other hand, if it is negative, it decreases the heap segment space. And the return value of sbrk is a pointer to the beginning of the newly allocated region if the call is successful. On the other hand, it returns void star -1, which is an invalid pointer if at all there is any error in the execution of the sbrk system call. The last system call is intmprotect, which takes again 3 parameters. The first parameter is address, which represents the starting address of the memory region for which you want to change the memory protection level. The second argument is length, which represents the length of the memory region in terms of bytes for which you want to change the protection level. And the third one is memory protection flags, which include protection underscore read if you want to give only read permission, protection underscore write if you want to give the write permission, and protection underscore execute and if you want to allow the instructions to be executed. In such a case, you can use this flag, protection underscore execute. And this MProtect system call returns a 0 value on success and it returns -1 on failure. And if you want to know what is the type of error that has been occurred during the execution of MProtect system call, you can use the variable value error number, which represents the type of error that has been occurred. So in this session, we have discussed the 4 important system calls which are related to the memory management, which include MMapping, memory mapping, memory unmapping, MProtect, and sbrk. These are the 4 system calls that we have discussed. So with this, we came to the end of this session and we again meet in the next lecture. Thank you.